Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question's asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4. Which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22. So it's going to be 22 sweets. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy. And the way we do it is to use a simple formula to find the position of the median. Now the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now, to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group, so it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there, 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the third one is the last number in that group. The fourth one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all we need to do is copy down exactly what the group is. So it's 40 to 55. And don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top. So times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20. So we times that by 4. And so we've got to times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left-hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A. And we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs on the page when you do this to make sure you get full marks. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in twos. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. First thing I'm going to do is just draw the square out. And we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the four lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13. So it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1. So we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number. So it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power of 4, w to the power of 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power of 4, w to the power of 5. Some people will try and do something with the v to the power of 4, w to the power of 5. But if you think about it, if I just draw out my square, if it's 11v to the power of 4, w to the power of 5 all the way around, when you add, you don't add the v to the power of 4, w to the power of 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power of 4, w to the power of 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11v to the power of 4, w to the power of 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power of 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power of 5 together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can times top and bottom by 3. And that would be 16 over 75. So either 48 over 225 or 16 over 75. So the first thing we notice is the coefficients of the x's and the coefficients of the y's are different. But if we look at the y's, they are very similar. So we've got 3y and we've got 6y. So all we need to do is times everything in the top equation by 2 and then they'll be matching. So we're going to write out the first equation again. And what we're going to do is we're going to multiply everything in it by 2. And so I'm going to write that equation again, just so we can match up the equations nicely to be able to do our simultaneous equations. And I'm going to write the second equation just as it is, because it's already 6y. And get my bubbles in, because obviously we're working downwards. Now we're either going to be adding or subtracting these, and the way of telling is looking at the sign before the 6y's, the matching coefficient, and if they're the same, then we subtract. If they are different, then we add. Now these are both the same, they're both positives. So we are going to be subtracting. So we're going to subtract the top ones from the bottom ones. 10x take away 6x is going to be 4x. 6y take away 6y is nothing, which is good, because if we're left with any y's here, that means we've made a mistake. And 70 take away 54 is 16. And let's get our lines in, because we need to solve this last bit by dividing 4 both sides. And so we've got x equal to 4. Now that's only half the job because we need to find out what y is. So what I'm going to do is just copy this first equation but substitute in the value of x, which is 4. So 5 times 4 plus 3y equals 35. Get my lines in. And 5 times 4 is 20, so I'm going to take away 20 both sides to get rid of the 20. So we've got 3y equals 15. And then we're going to divide by 3 both sides. So we've got y equals 5. Now we can substitute in the values into the second equation. So 6 times 4 plus 6 times 5 does equal 54. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, we've got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45 and a is going to be 1 and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2 because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet or you aren't doing surds, is you times top and bottom by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle, because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3X equals, and then 66. I'm going to divide that 3 both sides. So we've got X equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of X minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2X minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. So for this question, we're just going to subtract the tops and subtract the bottoms. And so we've got 5 take away 7 at the top and 3 take away minus 3 at the bottom. 5 take away 7 is minus 2. 3 minus minus 3, well, 2 minuses make a plus, so that's going to be 6. So our answer will be minus 2 at the top and 6 at the bottom. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times the top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. This question is the same as questions you get where you've got y equals 8x squared and you've asked to find what y is when x equals 3. The questions are exactly the same, but instead of y we write f of x, and this is saying that the function is 8x squared and we want to feed in the 3 into the function. So it's going to be 8 times 3 squared. And 3 squared is 9, and 8 times 9 is 72, so the answer would be 72. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one. And normally we just put a little kind of line at the end here. So we're going to put a line at 1. And I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. When asked to simplify a surd, and this actually isn't a surd until we've simplified it, it means to get rid of, or to get the square root as small as possible. And the way we do that is we write down the factors of the 48 first. So we've got 1 times 48, we've got 2 times 24, 3 times 16, 4 times 12, and we've got 6 times 8. Now we want to look and see where the largest square number is. So we've got the 1 there, we've got the 4, and we've got the 16. So the 16 is the largest square number. And so what we're going to do is we're going to rewrite the root 48, but instead of root 48 we want to split it up into square root 3 square root 16, but always put the square number first. So I'm going to write it as root 16 times root 3. Now square root of 16, the reason we put the square number first is we can actually square root that. Square root of 16 is obviously 4. So it becomes 4 times root 3. And with surds we don't actually write the times sign between an integer and the surd. So it's just 4 root 3. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that, and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem, and you have to use those words, otherwise you won't get the marks. Now next I notice that we've got a set of parallel lines here, and we've got a line going through them. And so the 44 degrees there is going to be equal to this one here. And so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles. Put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here, and the bottom 2 angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees, and so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all 4 corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92, and again we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. If if we count the squares for 0 to 10, we count that there are 8 squares. And to get from the frequency 4 to 8, we times by 2. And so each of these will be multiplied by 2 to find out how many squares there are. But we're actually going backwards because we're going to count how many squares there are, and then we're going to try and work out the frequency. So for this second one, there are 12 squares below this line, and then these two here are 1 square. These two half squares count as 1, and these two count as 1. So it's going to be 12 plus 2, which is going to be 14. So 14 squares. Now, to get from the frequency to the amount of squares, we times by 2. So obviously the other way around, we divide by 2. So that would be 7. And counting the next squares, we're at 6 high and 2 across, so that would be 12. And so we're going to divide by 2 to find out the answer is 6. So the frequencies are 7 and 6. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. The way we expand these surds with the two brackets is very similar to the way we expand with quadratics. And so you may choose a different method for expanding. I'm just going to use the grid method. And what we do is we put the first bracket at the top, so it's going to be 5 and then minus root 2. And second bracket down the side, so 6 and minus root 2. And we just multiply them out, so 6 times 5 is 30. 6 times minus root 2 is just going to be minus 6 root 2. 5 times minus root 2 is just going to be minus 5 root 2. And now we've got two minuses, which will make a plus, and root 2 times root 2 is just 2, because root 2 times root 2, well, you can multiply the surds together, so that would be root 4, and root 4 is just 2. Okay, so now we've got to simplify this. Well, these two add together to make 32, and these two here add together, and so that would be minus 11 root 2. So comparing it to the a minus b root 2, a is going to be 32, and b is going to be, well, I mean, it's tempting to say minus 11, but there's actually a minus before the b here, so it's just going to be 11. So there are many ways to solve a quadratic, but in this question we're specifically told to complete the square. So I'm going to start by just copying down the question. And when we're completing the square, we're interested in the x squared and the x term. And we start by just writing down a bracket with x, and then we're going to add or subtract the coefficient of the x term, half of it anyway. So the coefficient of the x term is minus 12, so half of that is minus 6. Close the bracket and write squared. Over here we're just going to see what that gives us. So it'd be x minus 6, x minus 6, and that would be x squared minus 12x plus 36. So this creates a plus 36 we need to get rid of, so we're going to take away 36. Then we've got the minus 20 from the question, and then it's an equation, so we get it equals 0. And then finally we've got x minus 6 squared. Add the minus 36 and the minus 20 together, and you get minus 56 equals 0. Now we solve it, so we get our lines in, and let's solve this. So I'm going to use all the same colour maybe in the equation now. So we've got minus 56, so we're going to add 56 both sides. If I get the right function, so plus 56 both sides. And that will give us, that will leave the x minus 6 squared on the left hand side equals 56. I'm going to square root both sides to get rid of the squared. So x minus 6 equals, and then square root of 56, we just leave as root 56. And then we're going to add the 6 to get x equals. And that will give us x equals, and then we've got a 6. Now, when you square root 56, you can get a plus or a minus. So it'd be plus minus square root of 56. So my answer would be 6 plus minus square root of 56. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. And that's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. So we're going to just quickly write out our sequence. So 9, 22, 41, 66 and 97. And we're going to find the differences of each of them. So that's going to be plus 13. Then we've got plus 19. So they're different already. We know that it's not a linear sequence. And that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3. 3 times 2 squared, which will be 12. And then 3 times 3 squared, 27. 3 times 4 squared, 48. 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. When you have a minus in the brackets in the function, you're going to reflect it in the y-axis. So we're going to have to reflect this in the y-axis. So we need some kind of understanding of what the sine wave does before it gets to 0, 0. And it starts by going up. So when we go backwards, it actually goes to -1 at 90. And then it will go back up, or at minus 90 I should say, then go back up to 0 at minus 180. So what our graph is going to do, because it's reflecting in the y-axis, our graph is going to go down to 90, go down to -1 at 90. Now a sine graph normally goes up, but this is going to go down. And actually it's going to look very similar to if it had reflected in the x-axis, but that is not what's happened. It has reflected in the y-axis. It just happens to be identical to if it had reflected in the x-axis. So it's going to go down to -1 at 90, back up to 0 at 180, and then just keep going with its cycle. It's not great. We need to cross the coordinates, but as always, make sure you have nice, smooth U shapes at the bottoms and the tops, and that's more than good enough to get the marks. A line that has a gradient of 0 will just be a horizontal line. So if you get your ruler and you just have a horizontal line on your ruler, so just have it as a gradient 0, and just keep moving down this graph until it becomes the tangent of the curve. So if you see, it becomes a tangent to that curve here. Where is it a tangent to? Well, it's a tangent to this coordinate here, which is at x equals 2.5. So we've got x equals 2.5, and you can see the y is 2. So the coordinates are 2.5 and 2. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.